Hello everyone, welcome to the next session on operations research. In this session, we will discuss the concept of classical EOQ model. Here, the demand rate will be uniform, replenishment rate will be infinite. The classical economic order quantity, that is EOQ model, is a fundamental inventory management tool used to determine the optimal order quantity that minimizes the total inventory costs, which include ordering costs and holding, that is the carrying cost. Introduced by Ford W. Harris in 1913 and later refined by R. H. Wilson, the EOQ model is widely used in operations management, supply chain management, and inventory control. So these are the areas of use of EOQ model. Key concepts. Demand is indicated by capital D, the total quantity of a product required over a specific period. Ordering cost, it will be indicated by capital S, the fixed cost incurred each time an order is placed regardless of other quantity. Holding cost, capital H, the cost to store 1 unit of inventory for a specific period, typically a year. Economic order quantity, EOQ, the order quantity that minimizes the total inventory cost. So if you want to reduce your cost of ordering and holding and you want to find a midway, then you go for economic order quantities such that the total inventory cost is minimum. Assumptions of the EOQ model. The classical EOQ model is based on several simplifying assumptions. The first one is constant demand. The demand rate for the product is steady and known. So say for a period of a year, every time you have to place a demand for the product, say you place a constant demand of 100 in quantity of a raw material. Constant ordering cost, the cost to place an order is fixed and does not vary with the order size. So if your order size is say 100 or 150 or whatever it is, the cost of ordering this quantity is going to remain the same. Constant holding cost, the cost to hold 1 unit of inventory is constant. So if you are holding 100 units of the inventory, the cost will remain constant for holding such kind of inventory. Instantaneous replenishment, the entire order quantity is received instantly when an order is placed, resulting in zero lead time. Lead time, as you know, is the time between placing an order and receiving an order. So if you have zero time in between this, that is you just place the order and you receive the material, then that is called as instantaneous replenishment. No stockouts, there are no shortages or back orders. Inventory is replenished before it depletes. So if you have placed an order of say 100 quantities and over a period of time this gets reduced to 50 because you have used and it further reduces to 30. At this point you make an order and then your replenishment is done of 100 more quantities. So in that case you don't have to face shortage even when this 30 reduces to 0 in the next process of making the products. Single product, the model applies to one product at a time. So it could be a particular product, say a soap, or maybe you're manufacturing towels or some water bottles, whatever it is, but there will be only one product at a time in the shop floor. No quantity discounts, the purchase price per unit remains constant regardless of the order quantity. So whatever order you have made, you will get it at the set price. There will be no discounts made. Because when you talk about discounts, there are different models for it. EOQ formula. The EOQ is calculated using the following formula. EOQ is given by root of 2ds upon h, where D stands for the annual demand in units, S stands for ordering cost per order, H stands for holding cost per unit per year. So if you know these values, you can substitute and get the value of EOQ. We will see how is the formula derived for calculating the economic order quantity. To derive the EOQ formula, consider the total cost TC as the sum of ordering cost and holding cost. So this is very important. What are the two quantities? One is ordering and one is holding cost. Now if you observe over here, this is a diagram for the derivation. On the y-axis over here, I am showing you the order quantity, that is Q. As I said 100, now the variable over here is Q. On the x-axis is time. So you can see here that initially this is the order received Q, and over a period of time this quantity reduces. And then it comes to a particular value over here when you place an order. So you can see this is a lead time, this value. So here you place the order, you receive the order over here. So as soon as your stock is reduced, you can see that again the replenishment of Q items are done, and then again the process will continue. Here you place the order at this point, and then again when this goes to 0, here the replenishment is done. So this is your instantaneous replenishment. As soon as you lose out on the material, there is a order received. So here you can see this is order placed, this is order received over here. Again order placed, order received, and this will continue. You can see this is the reorder point over here. That's when you make the reorder. And this is indicating, y-axis is indicating the inventory level. Demand rate, as you can see, is constant, that is Q. Now we will talk about the formula for the various terms. One is ordering cost. If Q is the order quantity, the number of orders per year is D by Q. Because Q is the order quantity and D is the demand. Thus, the total ordering cost is S into D by Q. You can see here, S is the ordering cost per order. So this will be ordering cost per order into demand upon the order quantity. Holding cost. The average inventory level is Q by 2. How did we get this? Here it is Q and here it is 0. So when you take 0 plus Q average, so this becomes Q by 2. Therefore, the total holding cost is H into Q by 2. Now what is H? It is the holding cost per unit per year. So you need to multiply that with Q by 2. Total cost TC, as we have discussed, it is a summation of this ordering cost and holding cost. So this is S into D by Q plus H into Q by 2. Now, we have to minimize the total cost. So when you want to minimize something, according to mathematics, what you do is you derivate that and you equate it to 0. So here to find EOQ, take the derivative of total cost with respect to Q and set it to 0. So here you can see it is derivative of this TC. TC formula is S into D by Q plus H into Q by 2, and this derivative will be equal to 0. So when you have to derivate this, S and D will be constant. You are derivating with respect to Q. This is like this, 1 upon Q. Derivative of 1 upon X is actually X inverse. The formula is n x raised to n minus 1. So it is minus 1 into x raised to minus 2. So this becomes minus 1 upon x square. So this will have derivative as minus 1 by Q square. So here you can see SD are constant, minus 1 upon Q square. And derivative of Q with respect to Q is 1 because H is constant and 2 is a number. So this becomes H by 2 is equal to 0. Now since right hand side is 0, we can shift this negative term to the right. So this becomes H by 2 is SD upon Q square. We want to find Q square, so keep Q square here and rest of the terms you can cross multiply. So Q square is 2 into SD upon H. So Q will be root of 2 SD by H. This is the economic order quantity, which you can use Q or Q star as I have shown in some other PPT. That's acceptable. Now there is an example calculation here. Problem statement, a company has an annual demand of 10,000 units. So this is D. For a particular product, the cost to place an order is $50. So this is going to be your ordering cost, S. But S is written as $50 per order. So please be careful because it is written place an order. So per order you can say. The holding cost per unit per year is $2. So here I have written H is $2 per unit per year. Calculate the EOQ. Now we know that EOQ has formula root of 2 ds upon H. Here you can just substitute the values and you will get this answer approximately as 707.11 units. So what is the interpretation of this value that we have got? The company should order approximately 707 units each time to minimize the total inventory cost. So if you see here, this diagram, this value of Q is 707 units, which should be placed here at this reorder point, but this will be replenished over here, 707. Now, next we'll see the graphical representation. Typical EOQ graph showing the total cost curve with its minimum point at EOQ. Ordering cost curve decreases as order quantity increases. We have already discussed this. If you order in bulk, your ordering cost will be less. But if you order in small batches, then your ordering cost is going to increase. So that is shown over here. Ordering cost. As you can see, this x-axis is indicating order quantity, how much you are ordering. This y-axis is indicating cost, annual cost. So as the order quantity increases, as you go towards the right, you can see that your ordering cost is going to reduce. So you can see this curve for that, the first one. Next one is the holding cost curve. It will increase as the order quantity increases. It's obvious, if you order more in quantity and you keep in the warehouse, then your holding charges are increasing because you're holding the material to yourself. So if you see here, this is the line, this linear line which you can see, this is 2. So this is 1 and this is 2. So these are the two lines. Now when you find out the total cost curve, it is a U-shaped curve where the minimum point represents the EOQ. So this is the curve, number 3. So this is total cost curve, which is a U-shaped curve, and this is the minimum value, the lowest point on the curve. So this is indicating the optimal order quantity Q star or Q, whatever you want, and this is the minimum total cost on the y-axis. So this point, since it will have two values, x and y, like any other point on the graph, so x will indicate the value of EOQ and y will indicate the total cost, which is minimum value. Next, we will talk about the advantages of the EOQ model. The first thing is, it is simple, so we are talking about simplicity. The model is easy to understand and apply. Second, cost minimization helps in identifying the order quantity that minimizes total inventory costs. Decision support aids in making informed ordering decisions and inventory management. This is very important. Benchmarking serves as a benchmark for evaluating actual inventory performance. So once you know that you have to order in a particular quantity, then accordingly you can evaluate your inventory and you can set a benchmark of this value. Limitations of the EOQ model: assumes constant demand. Real world demand can be variable and unpredictable. This is something that we are aware of. Ignores stockouts. The model does not account for potential stockouts or shortages. So this model is completely ignoring any situation of stockout or shortage that can happen. This is again a limitation of this model. No quantity discounts. It assumes that the unit price remains constant regardless of the order size. This actually does not happen in real life because you will definitely ask for discounts from your supplier and the supplier definitely gives you some discount. So this model completely neglects that fact. Single product focus does not consider interactions between multiple products or shared resources. So that is also possible. For example, there is a small thing like you add some kind of tags to your material of your company's brand. Those kind of items are shared amongst many products of your company because you will not be producing only one product. You will have multiple products. So in that case, when you're focusing only on a single product and calculating, then it becomes difficult to order. Instantaneous replenishment assumes orders are received instantaneously, which is rarely the case. It actually does not happen that the lead time will be 0. You place an order, you immediately get an order. It does not happen. It obviously takes some time. Even if you are bringing the order from your own warehouse to the shop floor, it will definitely take some time. So this kind of instantaneous replenishment is not exactly possible. The last one is static model, does not adapt to changes over time such as fluctuating costs or demand. So this is not a dynamic model, hence this is the drawback of this model. In the next session, we will be discussing in detail about the limitations of EOQ model because it's a very important concept to discuss, because if you shift to any other type of model, then what is the limitation of EOQ that we have shifted to some other model needs to be thought about and discussed. Extensions and variations. So as I told you that there are other models too. To address some of the EOQ model's limitations, several extensions and variations have been developed. The first one is EOQ with quantity discounts. Incorporates price reductions for larger order quantities. So suppose if you have large order quantity, you will ask for discounts, supplier will give you discount. So you can use EOQ with quantity discounts at that time. EOQ with planned shortages allows for intentional stockouts under certain conditions. So it is possible that you have some planned shortages because you really don't want to continue with the product maybe. So in that case, you can have a shortage, or maybe you really want to have a break in the work because you want to focus on some other production. So in that case, this is a planned shortage. So that also can be incorporated. EOQ with multiple products extends the model to handle multiple items considering shared resources. So this is again a very beautiful model where you can have multiple products that are present in your company and they can be handled simultaneously. Dynamic EOQ models adjust the order quantity based on changing demand or cost parameters over time. So this is again a very realistic type of model where you are talking about the current market scenario and then deciding on your economic order quantity. EOQ with lead time incorporates the time lag between placing and receiving order. Now this is something very obvious. So EOQ with lead time is a very realistic approach of dealing with the problem. So as you saw the various limitations, these kind of extensions or variations, whatever you call, have been developed and brought into the market such that the EOQ model becomes much better. So now we come to the conclusion of the session. The classical EOQ model is a foundational tool in inventory management, providing a straightforward method to determine the optimal order quantity that minimizes total inventory costs. While it offers valuable insights and serves as a starting point for more complex models, it's essential to recognize its assumptions and limitations. So this is also important. Before you go to study advanced models, you should know what is the basic model. In practice, businesses often need to adapt or extend the EOQ model to better fit their specific operational conditions and dynamic environments. So companies will decide what is their condition and accordingly use the correct variation of EOQ model. Effective inventory management, leveraging models like EOQ, contributes significantly to a company's operational efficiency, cost control, and overall profitability. So when you are using the EOQ model with whatever variations you need, or maybe the classical EOQ model, which is the original one, you will be ending up with operational efficiency. So your operations will be quite efficient of the company. There will be cost control so that you don't spend extra either on ordering or holding. And there will be an overall profitability to your company. So with this, I end the session on classical EOQ model. I hope you have understood the lecture. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.